Right, so we're going to go over Git. I'm only going to go over some of the more common uses of Git. I don't want to bore you. Yes?
I think you want movie recording?
No, screen recording.
Oh, screen. Okay,
Yeah,
sorry.
yeah.
Sorry.
So I'm going to go over some of just the more common aspects of Git, but there's a much more extensive set of coverage in the examples and the cheat sheet. All right, and so we expect that you're going to be using Git using those examples. All right, so read through them. They're fairly detailed, right, and give you examples on how to do things and how to not do things. And so when you're going through the assignment that perhaps you might have already started, I don't know if I see maybe half of you it looks like you've already started. Have you half of it haven't? Make sure you follow these examples, right? Lest you be deducted points, right? So make sure you read through that. So let's go over some of the more common aspects of Git, right? So Git short. This is a short version of Git. All right, so as you might have known already, Git is a source control tool, and typically it's used for developers to collaborate. Right? We're gonna decide on a centralized source of truth. Right? It's going to be the collection of all the source is going to be in one place, and it is always going to represent the latest of the accepted piece of software that presumably has been deployed and delivered. Okay, we all as participants of the team, we might have slightly different versions of what's in this centralized, what we call the master version. That we might have slightly different because we might be either fixing a bug or working on a new feature, right? And because this is a shared resource, we have to follow some rules. Now, just like if we are a traffic light, right? We can't all at the same time go through the traffic light, right? So there's some traffic light in there that says, well, you first and then me. Or if there's a stop sign, a four-way stop sign, well, we follow certain heuristics, right? On how do we behave in a shared environment. Yes? So same thing in Git. And now, typically, hopefully, if we follow these rules, that we won't have any conflicts, any issues, no crashes. And there's some of the analogies that you might consider is, imagine you are working with a shared document like Google Docs, say, and on the same document, right? And if you're working on, perhaps if someone is working on way at the top of the document and someone is working way at the bottom of the document, then the piece of software is pretty smart at merging your changes automatically, right? Your changes up there don't affect any changes at the bottom, right? And they're both being merged onto the same document. Yes? So same thing with Git. If you're working in a document and I'm working in a completely different piece of a file system, they're all just being merged into master implicitly. There's nothing to do. Even if we're working on the same document in the same piece of software, right? Same file. If someone's working way above and somebody's working way down on a piece of JavaScript or Java, again, Git will make a best effort to just merge those implicitly, right? We just have to keep track of those cases in which inadvertently, right, I was editing the same lines of code that you were also editing, right? You were working fixing a bug where I was working on a new feature, right? And when we go and merge, Git is going to say, well, it's the same exact lines of code. What do I do? Right? So it's gonna let us know that there was a conflict, right? And and the only person who can determine whether on how to resolve this conflict has to be a human intervention. Somebody has to go in there and look at the source of code and say, well, these are my changes, these are your changes. Which ones do I take? Yours or mine, or a combination of the two? Okay. Somebody will have to use human judgment on what to do. Ideally, this would never happen. Okay? If you follow some common courtesy, some common knowledge on how to handle this should never ever happen. Okay, conflict should be extremely rare. Right? Typically, the easiest thing is that you notify everybody and says, "Hey, I'm going to be working on this file," and nobody touch it. Right? Actually, some systems allow you to block or lock the file, right, and say that while I'm using it, while it's checked out, while I have it, no one else can edit it, right, because I have it. And until I leave it, until I unlock it and commit it back, then it will be available for somebody else, right? Kind of what you might have seen in databases where you're doing transactions, right? You might have a pessimistic locking algorithm or an optimistic locking algorithm, right? No databases? Okay, never mind. So we have to handle possibilities of collisions and how to handle them. So ideally, you come in the morning and the first thing you do is do a command of go fetch me the very latest thing that is out there in master, right? And it goes out to the remote repository and it copies it back. Yes.
Can you go over what are the differences between fetch and pull and checkout?
So checkout is just from the repository, from your local repository, the latest copy that you have just copies it into your workspace, right? So if you have any latest version on the physical file system, right? It fetches it from a local copy of repository, right? Your staging, it copies it and overrides any things that you might have. Oftentimes, that's one of the easiest way to just just throw away any of your changes, right? From the latest that you might have from staging, right, in your local machine. Fetch grabs something from the remote repository, brings it to your staging, but it does not override any of your current changes. It doesn't merge it into your local file system. Whereas pull does both. It fetches it, puts it in your staging, and also it overrides any new things that you might have. So you might have to be careful there, right? Okay. So the first thing you might want to come in and pull, right? Do a pull from your remote repository. And see if you find any conflicts. Ideally, you will not see any conflicts. You'll have any changes that other folks have been working overnight or towards the end of at the end of the day. Yesterday, I left early. I didn't see the latest changes from everybody. I will see their changes, their new files, new changes to other files that I might have. Ideally, they haven't touched the files that I was working on, but they could have. Right? They could have, right? And if they could have worked on the same file that I was working on, ideally, it would have. They would have been working on a different section of the file, and Git would have implicitly merged both our changes. Right. So now I have the stuff that I was working on plus the changes that anybody else might have worked on. Yes. Right. And ideally, what I want to try to do is stay as close as possible to the centralized remote master, as close as possible, so that I don't deviate as much as, from the masters, because I want to avoid. Once I'm done with my feature, with what I'm working on, I have to put it back and merge it back, right? I don't want to have any conflicts by the time that I'm done, right? So as long as I just keep pulling, and I'm always up to date with whatever other folks are working on. Yes, right. All right. So typically, what happens is that we are either giving a bug to work on or a new feature to work on, and that feature typically is listed either on Jira or listed on GitHub as an issue, right? And typically that issue or Jira ticket will have a naming convention. Typically we'll have some unique identifier, right? Maybe an acronym plus some numbers, and then a short title, right? Plus a long description. So typically when I work on that bug or that issue, I create what is called a new branch, right? I create a brand new branch, which is a kind of like a copy of the latest things that I have, right? But it's going to be a working copy. I'm not going to touch the pristine copy that I had, right? I'm going to have a branch off of that where I'm going to do all my work, fix the bug or implement a new feature, add new files and whatnot, right? And it might take me a day, maybe a couple of days. Meanwhile, while I'm working my branch, other folks in the teams are doing the same thing. right? They're working on their bugs and their issues and their tickets, yes? And they're creating their own branches, correct? And they might finish before me, right? And they might be merging back into master. That's why, as I am progressing in my branch, I should make every effort to pull in, right, any of the latest things from my master to make sure that I'm up to date with what other folks might be working on, right? And if there are any conflicts, well, I'll try to resolve them as quickly as possible. Yes?
You're branching off of local, correct?
Yes. But making sure that my local is a latest copy of master. Yeah. So as I'm working and I'm done with my feature, right? I created all my tests. I ran it. Everything runs locally. Nothing is broken, and I'm content that this is okay. I don't merge into master. I don't say I'm done. Right. What I do is that instead I push my entire branch up to GitHub, right? And then ask someone else in the team. I create what is called a pull request, right? A PR, so basically what I'm telling other folks to do is to review my code. I'm asking someone else, hey, are you willing to debug this tomorrow? Is it okay if this is buggy and you fix it tomorrow? I'm asking that they take ownership of my code, of whatever I wrote. I wrote it, and I'm asking, are you willing to maintain this tomorrow? Right, to be called upon to fix something that I might have broken, right? And so this is something important, right? And someone says, "Wait a minute, you're asking me to be responsible for your code?" Exactly, right? It's not the code does not belong to any one person. The code belongs to the team, okay? And so we have someone else look over our shoulders, look at what we have generated, what we have coded, and we're expecting a discussion, right? A dialogue on this is great, this is awful, or here are some suggestions. So there will be a dialogue as part of the PR, right? And Git will keep track of our dialogue. They'll say, oh, you know what? You should add some comments here. Why don't you rename this variable this way? Why did you use linked list? Why didn't you use an array list? So there'll be a dialogue back and forth, and the ones that we agree on, I'll work on. I'll do a push again, right? I'll push my branch over and over until we come to a consensus, right? And perhaps I've assigned it to 2 or 3 folks to take a look at this, but make one of them responsible. So you are responsible to merge this. Once everybody comes to a consensus, that person merges it back into master. They have now taken ownership of that source code. If tomorrow something's wrong with that source code, it should be okay for that person to come back and fix it, even though they didn't write it. Right? So the source belongs to everybody. Gets merged. Typically, the merge will kick off several automated things. Okay? In a mature system, there will be an automated continuous integration system, right? That will start off, kick off a whole bunch of tests. Hopefully, they're exactly the same tests that I ran on my local machine, right? They all passed. Ideally, those tests will pass also. Because I just did it on my machine, hopefully those tests will also pass on the remote machine. Those tests pass. If they pass, then everything gets merged. It gets packaged, compiled, packaged, and then deployed into QA. Typically, gets deployed into multi-tiered set of environments. First into QA, right, so that the QA folks can now take a look at it and manually test it or run their automated tests to see if it works. Yes. And if it passes the QA, typically what happens is that once I'm done with my test and I've merged it in, I move my ticket to saying that it's ready for QA, right? And then the QA folks will take it. They'll try to break it, right? They'll go through the steps that we have previously agreed on how to test this manually, right? And if they accept it, then it goes on to UAT. Right, meaning somebody, the product owner, right, or the business analyst will come back and actually we'll demo it to them, right, because they are the proxy, they are the representatives of the end user, right, of the business. They'll accept it, right, once it passes UAT, or the ticket has gone through several stages, right, from to do to in progress, ready for QA, ready for UAT, right? And once the UAT passes UAT, then finally we can say that the ticket is done, right? We can move it on to it's done, right? And that might take several days, a whole week, maybe perhaps, to go through this whole process. So it's very laborious, right? It's very laborious. From us developers, when we're done, it compiles and passes tests. We tend to think that we're done. Okay, it's not done, right? It has to go through quite a few other steps before we all consider it to be done. So anyway, let's focus on the Git part of this. Right, so Git is the tool that we're going to be using to collaborate in the source space. And if you have a Mac, more commonly if you have Xcode and you have installed it, some development environment like Xcode, you should already have Git installed on your machine. If you're on a Windows, you might need to download a Git client, and you can start it off by typing Git bash on Windows. So Git keeps track of multiple versions of the source, right? There's we say that Git is considered to be a distributed source control system, okay, where at any one moment we all have a copy, right, of the entire source code, right? That anyone in the team, right, has the latest copy of the source code. Or we might have slightly different versions as we're working on different features and bugs and whatnot. But ideally, we all have a local repository, which is a copy of some remote repository, right? The remote repository is a machine that, just like anybody else's machine, has a repository. And we have all agreed on the team that this is the one place, right, that is always going to have the very latest of the accepted code that is currently in production, that is currently the one source of truth. But technically, it is no different than anybody else's Git instance. Okay, is that we have all come to an agreement that this is the one single place of source of truth, and we all point to it from our local machine and say, okay, that is a remote repository from which we're all going to copy down into our local repository. Okay, and that local repository, hopefully it's the same for all of us up until we start working on a particular feature. We then have a staging area that keeps track of any changes we might have made to the local repository. The local repository is it contains all the files that Git is keeping track of. Right? Git doesn't keep track of every file. You need to tell Git what to keep track of. There's many different files that we don't want Git to keep track of, right? Any libraries, any jar files, war files, any configuration files, any IDE specific XML configuration files. None of that is really part of our source code, right? Those are just artifacts, right, that come and go as we interact with the development environment, right? So not all files we want to keep track of. Typically, we only want source files, right? JavaScript, HTML, CSS, Java files, okay? Maybe POM files, XML files, things like that. But .classes, right? We don't want those to go in there. Any libraries that we need, we don't want any of that to go in there either. So the local repository keeps track of everything that's being tracked. The staging area keeps track of those things that have been modified it keeps track of the changes that have occurred locally on your machine from the local repository, okay? And so which is represented as the local files that you're editing. And if you ask it, what are the differences between anything that you've been working on, it'll tell you, what are the changes from the local repository? What are the differences? What lines have you added? What lines have you deleted? Any new text that you've modified? And it all starts with you either cloning or pulling down multiple times from the remote repository to make sure that you always have the very latest on your local machine. All Git commands start with Git. we have Git and then a verb, options, and path. And again, there's a plethora of commands, and many of them are kind of redundant. That you can do the same exact thing with slightly different syntax of different other commands. Right? That's what makes Git somewhat challenging. And some folks like to some idioms of Git of doing it one way, but you can do it certainly another way. So please go over the extended version of this file, of this presentation, to look at some of the examples on how to do it, do certain things. So ideally, it all starts with the repository is empty, and we start adding files. And you add them by using the add command. What this tells Git is that Git at first is not tracking anything. You can create all the files you want, you can make any changes, but not until you add those files to Git will Git start actually tracking changes. All right? So you might create a brand new files, and we tell Git, hey Git, start tracking any changes to this file. You say Git add and the file. After that, Git will start seeing what changes have you made lately to that file. You can add multiple files or any new files have been added by saying Git add dot. Any new files will be added from that directory. So Git add dot, or you can tell Git to stop tracking a file, right? By saying Git rm file. This doesn't necessarily remove it or erase it from the file system. It just tells Git stop, remove it from the repository. Right? Stop tracking it. I don't want you to track it anymore. Okay. Once we're okay that our test has run and we run our unit tests and our or integration tests or whatnot, or our automated Selenium tests or our user interface tests and whatnot. Once we're happy, we're going to make those changes permanent. Well, permanent locally, right? By using what is called the command git commit. Right? It says I'm done. I'm with my changes. I've added these files. I've added these lines of code. I'm happy. All my tests passed. Locally, I'm going to make those changes permanent, and then they're made. The changes are made permanent into a local repository. All these changes, all these repositories are maintained in a local directory in the directory of your project, wherever your project is. There'll be an additional hidden directory that starts with a dot. It'll be .git, right? Everything that Git is tracking, it'll be under that one directory. If you blow away that directory, you've removed anything that Git was tracking will be gone. You can always pull it back and recreate it from the remote repository. Typically, you also add a message using -m and then the message. Typically, these messages have certain syntax, right? You can write whatever you want, but typically the team will come to an agreement on the syntax of that message, right? Usually, it'll contain the ID of the ticket or the issue that you were working on, right? There'll be some long, huge requirements document where all these requirements will have a unique identifier. Each requirement will have a unique identifier, right? Ideally, these requirements will be converted into stories or tickets for somebody to work on, yes? And so to maintain traceability between all the requirements and any line of source code that you've ever written, right? You will include the ticket as part of your message, okay? You will also, some teams will also ask you to add or include in your message a URL that links to the ticket, right? That might be listed on Jira or some other project management system, right? So that somebody can click on that and look and read the original ticket, right? The original problem or the original requirement, right? Again, with the intent that we always keep traceability in mind, and also a verb phrase, maybe starting with a verb saying, added so and so or fix so and so, okay? And you'll say exactly what you did at a very high level. If you really want to know what I did, you can look at the lines that I modified. Some systems can be configured to parse that message okay, and kick off a whole bunch of automated things, right? For instance, if you can configure it so that if you use the verb fix, right, or some derivative of the verb fix, it will automatically close the ticket, right? It will or automatically advance it to the next stage, right? Or automatically kick off a build, or automatically do all sorts of things. Okay. Again, the more mature a development environment you have, right, or the development team, it will have lots and lots of things automated, right, so that you don't have to do these tedious things from day to day, right. So again, a lot of things go about that one message over here. Okay? So be mindful with what you do. Once you're done with commits, you might have multiple commits, and the best practice is that these commits, these should be very tiny commits. It could be just one single line that you've modified, right? Or multiple lines. Typically, you want to keep them really small, right? Ideally, every time you reach a stable state of the application, right? You make a commit, right? And the idea is that if ever you paint yourself into a corner, right? It'll be very hard to undo things that might have taken hundreds of lines of code, right, rather than just a couple of lines, right? And ideally, what source control will allow you to do is to backtrack, right? It says, oh, I'm working on this, it doesn't work. It used to work. Why is it not working anymore, right? What did I do? What was the last couple of lines? Well, you could try to do undo, and see and try to see what actually you broke, right? Or you could use Git, right? You can just jump at a previous version of your commits, right? And see what is it that you broke, and you can see actually the differences between each commit. Yes, so it's a much more a mature way of undoing things, right? And jumping around in different versions. But again, this only works if your commits are small, right? And you wouldn't be required to throw away tons of hours of work, right? Only a couple minutes. So yeah, so commit often, commit small, right? Well, some of them obviously you might not be able to, like initial files or initial configuration files, things like that. That makes sense, right? But from a day-to-day, your changes should be tiny. Yes?
So if we're working on a ticket to fix a bug and we commit often, we shouldn't our commit message, we wouldn't say we fixed it if we haven't yet.
Right, exactly. So it depends how you configured it, right? To automatically close something, right? Yep. Right. It depends. You will have with a team, you will come up with a vocabulary, right? Of what and what structure will you have for those kinds of commits messages. Yeah. And everybody agrees on that vocabulary, right? Once you've done multiple commits, maybe 5 or 10 commits locally on your machine. Once you feel content that you want others to see your wonderful work, right? You will push. You will push to the remote repository. Typically, it'll push the branch that you're working on, not on the master. Typically, you would be working on a master branch, and then you'll notify. Commonly this will be automated so that everybody gets an email or gets a notification on Slack, right, saying, the repository has changed. Right? This is a good time for everybody on the team to now do a pull, right? So that everybody gets the brand new. I'm sorry, no, not yet. We'll get a notification that it has changed. Typically, the developer who pushed would now create a pull request, right? PR. Everybody gets the developer would assign somebody to take a look at it. You would go through a code review, a code walk together through what is that you made. The responsible person would merge this into master, and then once it's merged into master, everybody will get a notification say, "Hey, master has changed. This is a good time to pull, right, and get the latest onto your local environment." Right. So once everybody gets a notification, then everybody would pull and get everything. It would merge it into their local environment. Hopefully, it won't break their environment, right? So ideally, you haven't been merging something that would break everybody's environment, right? And everybody will know who it is, right? The other commands like git log allow you to see a list of the latest things that have been going on. including yours, your latest commits, or everybody else's commits as well. And you can filter any which way you want. Filter, in the last hour, the last day, the last month, or between certain dates. All sorts of things. You can look at the changes, the status. See, just list what have I been doing the last hour or so, right? So Git status tells you, oh, here it is. You've modified this, you deleted this line, you changed this here, da, da, da. So Git status tells you what have you been doing lately. Git diff allows you to see, it'll check to see ideally all the different lines that you've been modifying. Git init, if this is a brand new project, you can initialize it and start .git, create a .git directory and start initialize the project as a Git project. Git clone is what you're going to be doing for your assignment. Hopefully, everybody already has a repo, a remote repo. You're going to clone that repository. It's going to create a directory on your file system, and then from within that directory, you'll be doing all your works in there. Or you can rename a file using git move. Now, all your configuration, again, everything that has to do with Git will be under a directory called .git, right? So it's a hidden directory. And in there, there'll be also there'll be a configuration file that will keep track of your username, your password, your URLs, your remote repositories. You might have multiple repositories. They will be all listed under there. So you can configure that using the git config command, and there's a plethora of multiple things that you can configure. You can list the current configuration by saying git config -list. You can configure at different levels, locally on your local project or globally for multiple projects as well. So you can reuse configuration. As I said earlier, you don't want to have Git keep track of every single file. There's a lot of temporary files, build files, configuration files, package files that you don't want Git to keep track of. So you would list them all under the git ignore, right? And depending on your stack, the git ignore will have different content, right? If you're in Java, you will have certain in there. You'll have .class. You don't want all the library files. Typically you don't want any of the packaging files such as .jars, .wars, .ears. You don't want those either. But if you have Node.js instead, a JavaScript framework, then there'll be tons of libraries that are typically copied under the node_modules. None of those libraries you want Git to keep track of. So typically you would add that directory, that entire directory, in the git ignore, right? Also, if you're using Eclipse or IntelliJ or whatever IDE you're using, different ones will have all sorts of configuration files. None of those should also make it into Git, right? So you would list them in git ignore. In the assignment, I believe there's a link that links you to very common git ignore files based on the stack that you're working on. I would suggest to use the Java, the Java git ignore, right? To use that as your initial git ignore file. Okay. I believe the assignment walks you through using git ignore, and it creates already a default git ignore, so you should be okay, right? But we might need to add other things depending on the stack that we're going to be using in the front end, perhaps. Okay. Right. So as you commit, the commit will have a history of all the files that you've changed, right? All the lines you've changed, and it will uniquely identify your commit, right? It will give it a 40-digit hexadecimal number, right? That ideally will be unique. That would allow you to, at some point, be able to jump around at any previous commit that you might have had, right? Perhaps there was a release this month, right? And we kept working after that release. But there might be a bug. Somebody reported a bug, and we need to create a patch. We need to fix the bug and create a patch. Typically, you could jump back to that particular commit when the release was made, right? And work with the source code that was actually went out to production, which is currently in production and people are using, and it's obviously whatever's in production is behind any of the features that might be we've worked on for the last month or so. Haven't made it yet into production. Yes. So typically, I would want to go back to where I was in production, right? Fix the bug in a different branch, and then deploy that, right? Because I can't deploy the current code that I'm working on, right? It hasn't been tested, hasn't been approved, right? So what the commits allow you to do is, jump around into the past, right, at any point in time, and work with different versions as the code has evolved over time. And typically, the commits are represented as a long chain of commits. Each commit pointing to the previous commits, right? So each commit knows of all the previous commits, right? And the very latest commit, right, is pointed to by what it's called the head. The head always has the value of the latest commit, right? It's like a linked list. If you know the head, you can traverse that linked list. Yes? All right. So the head is very important. That's where it starts. That's where all the commits start. And then from there, you can navigate through the entire list of commits. So it's referred to as typically in capital, all caps, head. Right? And it's the very latest, pointing to the very latest in the chain of commits. So typically, here's master, and typically you would also have a head pointing to the very latest commit. And so whenever you're going to be working on a brand new bug fix or a new feature or whatnot, what you would do is you create a branch off of that master, and you would typically you would call that branch based on the feature that you're working on, perhaps the ID of the feature or the ticket or the bug that you're working on. In tandem, in parallel, the commits will continue in master, right? Because other folks are working on their own features, right? Their own bugs, and master is moving along. Yes. Ideally, you would have been merging into your own branch, right? Over here, we don't have that. They're kind of like progressing in parallel, independent of each other, which is a bad practice. Ideally, you would be merging, right, so that you're always up to date with whatever's on master. But here, we just want to illustrate, the fact that there's two versions. Your version that used to be the same, right, at some point, as everybody in the up until you branched off, and at some point that your changes. After multiple commits, you're going to push those changes, and somebody's going to accept or reject, and merge them back into master. Ideally, there wouldn't be any conflicts, right? But the more time you wait between merging the things that are in master onto your branch, the riskier it will be when you do your merge that there will be conflicts. Okay, and conflicts are just a pain in the butt. Right? So it's ideally you want to avoid them as much as possible. Right? You'll run into them. You have to deal with them. In the assignment, the assignment is designed to create a conflict. Okay, the assignment purposely generates a conflict, right, and walks you through fixing that conflict, right? Because you will run into it. So to create new branches, you can either list the current branch, all the branches that there are. You can just git branch will list all the branches. You can create a brand new branch by saying git branch and then the name of the branch. If you have multiple branches, you can switch between the branches, right? By using git checkout and the name of the branch. If you're working on a branch, and if you change a file, you make a couple of changes here and there, you could be asked to drop whatever you're doing. There's a bug in production. You have to work on that right now, right? So you have to drop your feature that you were working. This really cool feature that connecting to a website and retrieving movies and whatnot. You have to drop that and start working and fixing a bug. So typically, what you would do is that you want to create a branch. Go back to master. You pull down master. Right? And then create a branch to work on that bug. Yes? But typically what will happen is that your changes as you're working, and you've changed a couple of files, you can't just change over to a branch, right? Because what will happen is that if you change to that branch, your changes, whatever you were working, is going to be overwritten by whatever the new branch is, right? So typically, Git will stop you and say, if you change to that branch, you're going to lose your changes. So you have to commit. You have to put it in your local repository before you're allowed to switch branches, right? So you hopefully you come to a stable state of your source. You commit those changes. Your branches, your changes are now safe in your local repository. Now you can go to master, pull, right, and then switch to that new branch so that you can fix your changes. Yes.
Can you branch off of branches?
Yes. Yep. Yeah. You can have multiple branches. Right. So checkout allows you to switch branches. Probably one of the syntaxes that you might be familiar with is saying git checkout -b and then the name of the branch, right? That is like combining two of these commands, right? It first creates the branch and then it switches over to that branch, right? Again, Git has tons and tons of different ways of doing exactly the same thing over and over, so be careful. Just use these common use commands. Git diff allows you to compare two branches. Typically, for instance, if I'm working on something and you're working on something, I can pull down your branch, right? And I can have my own branch and I can compare them. See, why is it not working for me? And what did you do? Why is it different from what I have and what I have? So I could certainly do a git a checkout of your branch, have my own branch, and then do a diff, git diff branch. It says, ooh, look, you have this file that I didn't have, right? I have these libraries or these jar files that I didn't have. And then finally, merge. Merge allows you to, yes?
Is there a way to look at differences in a particular file?
Yes, you can say git diff. You could also point to either the name of a branch or you can do a directory to a file name. Yep. It knows how to handle it.
From one branch to the next, so from branch 1, and I want to look at the differences.
Yes, yeah, you can say branch / and then navigate down to the file. Yep. Merging branches, right? So you will come to occasions where there's going to be inevitably a conflict, and the way that Git is going to report those conflicts is that it will add additional text in there that will, with the intent of highlighting, what's theirs, the version, somebody else's version, with your version, right? We'll say, well, this is what it's in master, and this is what it's in your branch, right? And it'll show you the source code from somebody else's branch and what's in your branch, right? And then it says, I didn't know how to merge this. I was able to merge everything else, but this was in conflict. It was exactly the same lines of code. What do I do, right? And so your responsibility is to decide. Do I keep both, right? Do I choose theirs or do I choose mine? Right, those are really the three choices, and then remove all the extra characters, right? That Git has added with the intent of highlighting the changes, right? So it's your responsibility, or you can just abort it and say, forget it. I didn't mean it. I didn't mean to merge this. There might be way too many conflicts, right? And this would happen if you have waited a long time, right? From between merging somebody else's code, that's why you should do it often. If there is a conflict, ideally it will be a tiny little thing, right? It'll be something really small, and you can deal with that. But if you wait, conflicts can become fairly challenging. On how to undo, you can if you want to change the message of a commit, you can amend it. If you had a file that you've been working on and you forgot to commit, and you've changed a couple hundred lines, and you've painted yourself into a corner, and you can't find what's wrong with it, you might decide to just start all over. Just say, forget it. I just want to go back to where I was in my repository, whatever's in master. You can just check it out again, right? The file will be overwritten from whatever you have in your local repository. Or you can just reset. You can reset to head. Remember, head is pointing to the very latest commit in the repo, right? So basically, everything will be erased that you have locally. It'll look exactly with what you had in your local repository. You can do it for all files or for a single file, or you can just revert. Revert will bring it back to whatever that file was before you had before you had any changes, or you can reset it to a particular commit. You can look at with a log, git log. You can see all the IDs of all the commits. You can copy that and then you can paste it as part of the commit. He says, I want to revert it to how the file was 3 commits ago, right? Because I just realized that all the last 3 commits have been bogus. I just want to go back in time and get back where I was. You can also use reset and either soft, mixed, or hard that have increasingly more permanent effects on your local environment, right? Reset hard is the most dangerous. It'll just override your entire repository and bring it back to what it was from the remote. Yes?
If you went back like 5 commits and then you made changes from a commit, what happens to those extra ones that that gap? So like if you go back 5 and you commit, are those 5 above that now removed or?
No, they would stay. Everything stays, right? You're just now, you would generate a brand new commit, right? That would now go at the top, right? Overriding everything you had done in those 3 or 4 commits, right? So don't ever try to, I had these 3 commits. I wish those 3 commits never happened, right? You should not try to override those. It's just that I want to go to a previous version, and any new changes I'm going to commit, and they'll just become the very latest commit. Yes.
When these slides say repo, like, do they mean local or
Yeah, these are all local. These are all local. Yep. It's whatever. Well, ideally, you would have done a pull, right? And when you do a pull, then the local will be the same as the remote, right? Yeah. So synchronizing, you do a pull that copies from the remote repository. Fetch also retrieves it, but it doesn't replace and merge whatever you were working on. Push takes whatever you have in your local repository. Having gone from the working to the staging to the local repository, right? Push takes whatever you have in your local repository and just pushes it over to the remote. Or you can push to a specific. So git push will push to what it's called the origin. The origin is kind of like the default. It's a keyword for the default remote repository, right? And by default, it's the master branch that gets pushed, or the current branch that you're in. Okay. But if you want to specifically choose a different remote, you can have multiple remotes, right? One pointing to Heroku, or one pointing to AWS, one pointing to somewhere else, right? And you can name them, right? Typically, one of them will be named origin, right? And that will be the default remote. If you don't tell me which remote to push to, I'm going to use the origin remote, okay? But if instead you want me to push to some other remote because you're pointing to in Heroku or you're pointing to AWS or whatever, right? You'll typically have them different names. One of them you'll be named GitHub, one of them will be named AWS, and one of them will be named Heroku, right? And you can say push to and then the name of the remote. Yes.
Do you normally do a git pull before you do a git push, or do you?
Certainly, right? So typically you've done a pull, you've created a branch, you've been working on that branch for the whole day, and you do the push, right? And so that whole branch gets pushed to the remote.
If someone's done something on the master or pushed something while you were doing that branch, you should do a pull before you push what you've been working on, right?
Right, exactly. So you would go to master.
Yeah.
You would do a pull. Then you would go back to your branch, right? And you merge master into your branch, right? Resolve any conflicts, right? And once you're run your tests again, right? And once you're happy, then you push the entire branch to GitHub. Yeah. And then you create the PR. Yes.
2 questions. The first one is, I still don't understand the difference between pull and fetches. I get that it doesn't merge it, but then if you fetch it, then where does it go?
To your repo. That it again merges it onto whatever file you were working on. Right. So
Oh, okay, I understand. So it's
Yeah.
the difference between it being in your repo versus being in.
yeah. Right. So you won't see those changes in your file. Right.
Yeah.
So your file will still be your local file system. Right. Whereas the other one will not yet be merged into yours. Yep.
And the second question is that I still don't understand the difference between revert and reset.
Reverse is just a short for reset.
So
You know, reverse is for that particular for that particular git reset head file is the same thing as git revert. We're not saying anything.
Okay.
Yeah. Although revert allows you to even also specify the particular commit that you want to change to. Yeah. Again, there's multiple ways of doing the same exact thing, and that was one of the challenges of Git in general. Working with remote repos, clone. Right. So we've given you repos. Hopefully, everybody already has a repository, and you will be cloning down that from our. We're going to be using the school's GitHub, right? Not GitHub.com, but it's the school's GitHub. And as you're working, you'll be pushing things to the GitHub, the university's GitHub. And you can go there, go navigate to this website, right? And you can see all your commits listed there. You can see also the pull requests that have been created by other team members. You can create your own pull requests as well. Pull requests are basically requests to say, hey, I have this branch that I've been working on, and I want to put it in master. Right, and the pull request will check to see if there's any conflicts. It'll look at your branch, it'll look at masters, and will highlight any conflicts. If there are no conflicts, it'll put all in green saying no conflicts, ready to merge. Right, you'll assign to someone else. Someone else will get an email, and they will come and actually push on the green button saying yes, I am accepting these merges. Go ahead and actually merge it. I'm making myself responsible for this. All right.